Hello everyone, I'm Dr. Mehraei, and today we are going to talk about tutorial number 7. The video is going to be in two parts. First part is about constructing confidence interval for estimating the population mean, and the second video will be about constructing a confidence interval for finding or estimating the difference between means of two populations. Okay, first question. Assume that a population has unknown parameters. We take a sample with size 64 from this population and find out that mean and variance of this sample are 30 and 9 respectively. Construct a confidence interval to estimate the population mean with 98% confidence level. So, even before we check the cases that I explained for you in lecture 7, we can easily calculate error. It is 1 minus confidence level from the beginning. You can calculate it, which is equal to 2%. Next thing to do is constructing our confidence interval by distinguishing between the cases I explained before. So in all of the cases, the point estimator can be written first. So x bar, the mean of your sample, is the point estimator of the mean of your population. So x bar minus plus, or you can show it like inside an interval, and you have your reliability factor multiplying by standard error. In reliability factor, you can see I changed alpha over 2 to 1 minus alpha over 2. And the reason is that, first of all, they will give you, if you consider both of the numbers, they will give you the same answers at the end because of the symmetric property of normal distribution. But the thing is that since I want my interval to look nice from the beginning, that the smallest value happen to be on the left side and the bigger one to be on the right side, it's better to write it like this from the beginning rather than just order it at the end of your when you come up with the final answer and you want to construct your confidence interval. Okay, let's see how did I come up with this reliability factor. Why did I choose Z instead of T? Okay, so let's read it again. So the population has unknown parameters. I don't have any information about my parameters. This is a problem. And I don't even know what's the distribution of my population. Maybe it doesn't matter, we will see. We take a sample with size 64. Okay, the sample size is big enough. So whenever this is the case, we can say that we use central limit theorem in order to approximate the distribution by Z, standard normal distribution. So this is possible. So I don't even care what is the distribution of my population anymore because I can approximate it now with standard normal distribution. Okay, so this is the reason I can read it from Z table. And for my standard error, I used S instead of sigma. And what's the reason? Because I didn't have the information about the parameters. Okay, so please go through the cases very carefully. I selected only one question for all of the cases. You guys should go through all of the cases to practice yourself. Okay, let's see how we can assign values to it. First of all, alpha, we have calculated it. So 2% divided by 2, 1%, 1 minus 1%, 99%. So we already know how to deal with this one inside the lecture. We talked about it. But let's practice it together. So z-score of 99%. How can I find this one? So in standard normal distribution, we know that probabilities are happening inside the table. On the left side and the top, we can read the z-score from it. First decimal point on the left side, second one, you can see above. Okay, so let's take a look to find out where is my 99%. This is located in the middle of these two. There are different ways of approximations. One of them is that find which one is closer to the probability that you are looking for. 99% is closer to this one comparing to this. So I read 2.3. But for the exam, please do this approximation like getting the average of these two. So 2.325. in the middle of that. And there is another way to approximate it by the way I explained for you for the box plot in the previous lecture, which is the most accurate one. But in order to make it simple, we can just simply get the average of these two, which is 2.325. That's the value I've inserted for the reliability factor in the solution. And please pay attention here. This is S, standard deviation, not variance. That's why when I gave you information about variance, 9, you should get square root of that, which is 3. So after you calculate it, you will reach this confidence interval. What does it mean? It means that 98% I'm sure that the population mean, mu, will fall inside my interval. And that's why it's more accurate to provide confidence interval rather than point estimator. Because when you just mention about a point estimator, we could say, yes, this is unbiased point estimator. But we don't know how much we are sure about it. And this one, confidence interval, comes with a confidence level, which is the beauty of that. All right, in the next part of the tutorial, I'm going to give you an example about the case we are comparing population, means,